Hello everybody, I hope you guys are doing well. Welcome to section 10.6, a little introduction to special products and factors. In this section, the nice thing is we're going to continue with what we've been doing with multiplying binomials, section 10.4, and then with factoring trinomials, which was section 10.5, but we're going to try to find some shortcuts or some kind of tricks to take with some of the special products and factors that we see. Remember, when we're talking about trinomials, we can look at the general form of a trinomial is just ax squared plus bx plus c, and we'll come back to that in a little bit. The first thing I want to talk to us about is squaring a binomial. So we have a binomial like x plus 3, and the whole quantity is squared. One way that I recommend looking at this is that it's the quantity of x plus 3 multiplied to itself. That's what that squared term tells us, is that we have two factors of x plus 3. And then from here we can use our FOIL method. The x multiplied to x will give me x squared. The x multiplied to the 3 here gives me a positive 3x. Moving on the inside, 3 times x here is also a positive 3x. And then our last, 3 times 3, gives us plus 9. When we get our like terms together, that gives us x squared plus 6x plus 9 for our final answer here. Alright, what I want you to do now is pause the video and work on this example. We'll call this example 2, this was example 1, and example 3, which is up here. We'll get to this general rule at the end. So let's pause the video now to work on example 2 and example 3. Alright, hopefully with example 2 you were able to find that the final answer was x squared minus 6x plus 9. And with example 3 we should have had 9x squared minus 24x plus 16 there. If you weren't able to get those, make sure you rework those problems and try to find what your mistake was. The general rule here is the last thing we're going to look at, where we have the quantity of a plus b all squared. The rule states that if you have a binomial that's squared, what you can do is square the first term, so whatever a is, it gets squared. You're going to add that to 2 times a times b. You multiply a and b and double it, and that'll be the term in the middle, plus b squared. And you might have noticed that with some of these. For example, the first example, you square this, that's where we got the x squared, 2 times x times 3. Well, 2 times x times 3 would give us a 6x, that's where that came, and then you square the last one for right here. Same thing with all of these other examples. This rule right here is a general rule for any time you square a binomial. Alright, moving on to factoring a perfect square trinomial. Let's come here to this example. What we want to look at now is a trinomial that's considered a perfect square trinomial, and we'll talk about what that means. And we want to factor this. So if we look at it, we can set up our 2 parentheses, and then to get an x squared, we have an x, and we have an x, and then this is a plus 8x and a plus 16. Since both of those, b is positive and c is positive, we have 2 pluses here. And again, since the coefficient of x squared is 1, we can look for factors of 16 that have a sum of 8. And in this case, they're both x plus 4. A shorter hand way of writing that is the quantity of x plus 4 squared. Okay, but both answers would be appropriate for your final answer. Again, let's now work on example 2 and example 3 for factoring trinomials on your own. Pause the video to work now. When you have your answers, push play, and you can see the answers here. Alright, hopefully with example 2 you were able to come up with the quantity of x minus 6 squared. And with example 3 it was a little more difficult. It's still a perfect square trinomial though. It became the quantity of 2x plus 3 all squared. It's a little shortcut to remember these rules. If you look at it here, if you can take, let's see, if this c term is a perfect square, and you can take the square root, and if you look at the b term, and if it's twice whatever that square root was, it's going to work out. With example 3, you also have to have the fact that it was multiplied by 2 as well. Alright, we're going to work now with multiplying binomials. So our first example is x plus 7 times x minus 7. We can work through FOIL. This would give us x squared. The outer's a negative 7x. The inner's a positive 7x. And then our final gives us a minus 49. We can simplify that to just simply x squared minus 49. The middle terms cancel out because, as you can see here, they're opposites. So we actually end up with a binomial for our answer. Looking at the next example, 5x minus 3 times 5x plus 3. The shortcut, guys, for this one, you square the first terms. 5x times 5x will give us a 25x squared. We know that the outer and the inner will cancel. The outer is a 15x, the inner is a negative 15x, so those two terms cancel, so then you can just multiply the last. Negative 3 times 3 is minus 9, and that's kind of the shorter way for multiplying binomials that have opposite terms in them. And what we get is something called the difference of two squares. The difference of two squares. Because we have a squared term here, x squared, and a perfect square here in 49. Same thing here, 25x squared is a perfect square, and so is 9. We have a difference of two squares. So the general rule, again, when we multiply two things with opposites, is that we have the first thing squared, and then we're going to subtract the second thing squared. Because again, our outer and our inner cancel when we multiply these. So it's always just the first term squared minus whatever this second term is squared. And that's a little shortcut rule for multiplying binomials that have opposites. Alright, the last thing that we're going to talk about today on this video is factoring the difference of two squares. So now we're starting with something like this, and we're trying to find what are the factors. Our first example is x squared minus 49. So we're going to factor it into the product of two binomials still. We're still going to have an x and an x to get us x squared. And to get the negative 49, one of them is a plus 7, the other one has to be a minus 7. Okay, the only way that the difference of two squares is factorable is if we have two perfect squares, like 49 has a square root of an integer, and x squared has a square root that is a monomial term, and in this case just x. Okay, moving to the second example, looking at this one, 9x squared minus 25, and factoring that. I believe this looks a lot like the bonus question from the quiz. So we have 3x minus 5, the square root of 9x squared is 3x, and the square root of 25 is 5, and we're going to multiply that by 3x plus 5. Again, guys, you can always FOIL it out, multiply these to check that we get the right answer, but they will work out. And so in general, the last thing here is a rule for factoring the difference of two squares. If we have a squared term and we're subtracting another squared term, it's just the square root a plus b multiplied to a minus b. A couple others that I want you guys to try on your own and bring those to class on Friday to see how you did. So the first example here to try on your own is 16x squared minus 121. I want us to factor that, 16x squared minus 121, and multiply, so let me write factor here, and multiply. Let's go with 3x minus 5 quantity squared. Okay, work on those two examples, 16x squared minus 121 and 3x minus 5 all squared. Make sure you bring that to class on Friday, and I hope you guys have a great evening. Thanks, and math out.